Well, hello everybody and welcome to the second video this week from the Canal Sidings Model Railway channel. I'm going to do another Arduino project now that I've been working on. Very different from the previous one. I've got two cameras set up this time. I've got one looking here and I've got one looking over to my right at the screen of the laptop. Once again, I have these problems that no screen capture software seems to work for me properly. Not unless you probably pay 300 quid for it and then have to do that for every monitor, every laptop. I'm not prepared to do that when I've got 4 laptops on the go. Okay, so this is about something completely different, and this concerns a product that is available on the market ready built from a company called Megapoints Controllers.com, a company run by Dave Fenton. Clever guy who has done a wonderful job of producing small boards that will all fit together, all network together, talk to each other seamlessly, and do it all without any intervention from a PC. Here is an example of a Megapoints board. This one it's actually not a Dave Fenton version, so this, you won't find it looks like this. But this one is a kit which I bought, and these push buttons here are all you need, plus a couple over there occasionally, and these two LEDs to set it up to do almost anything, and that is really clever. This is effectively a Megapoints servo controller board, but this is a bodge that I've added to it along with this here. It drives up to 12 servos which plug into these 12 servo points, and the switches to control the servos go to these 12 here. So you flick that switch on and off and this servo goes, second switch drives this servo, etc. You can put some more switches here for memory operations, etc., and these are the grounds to return the switches to. I'm not going to tell you any more about how to set the board up because there are plenty of videos on megapointscontrollers.com which I advise you to go and watch if you've got any interest in Megapoints or any of the other layout modules that he's got, and he's got a lot of them. Then go look at his website, because there's lots of videos, there's lots of information, and you can buy the boards ready made, and as I say, they require no PC to set them up. It's an excellent system. Basically they join together via a network which just uses these little cables. This is a servo cable, 3-wire servo cable. It's actually Futaba stuff. I built this one myself, but basically it's got 3-way connectors, and you plug those onto the board. Oh, if I could do it like that, and take it to the next board, and those two boards can then talk to one another. You just press a few buttons to set them up. That's all you need to do. But as I say, go and see the Megapoints controllers. This one didn't come from Megapoints Controllers. Dave Fenton is also a member of MERG, the Model Electronics Railway Group, which you've heard me talk about many times. And he actually has given MERG the rights to sell his Megapoints controller, the servo version, as a kit. So you can buy it and build it yourself. Now MERG have made their own board, and as you can see, this is actually says Megapoints servo controller MERG. So it really is a Megapoints servo controller. As I say, you can set it all up with these buttons. It does everything that Dave's does. There's a little thing here that Dave's board has. Dave's board doesn't have this. But everything else appears to me to be identical. And it did work. Unfortunately, I've blown this IC up, which is actually, it's all based around the same processor as the Arduino uses. As far as I can make out, all Dave boards are based around the ATmega328 P or PN. Doesn't matter. The ATmega328 is the core, and that is what Arduinos use, and that's what goes in there. I've managed to blow that one up because the board flicked across my bench with a rather heavy cable sticking out of it, which I won't go into, and landed on a 6-inch steel ruler. and it was powered at the time, so it just expired. But that's why I can't actually show you it fully working. But the Arduino project around it is to do with not using switches along here to control the servos, but to be able to use a DCC accessory address for each servo. Now, Dave Fenton does have a DCC accessory address, a DCC accessory decoder on his website, which you can buy and plug directly into here, and then with a couple of button presses to set it up, you can then talk to all the 12 with 12 addresses, which you choose. Unfortunately, in order to control more than 12, you either have to buy one of these accessory decoders per Megapoints board, or you have to buy what Dave calls a multi-panel, I think it is. He may be able to do it with a mini panel, I don't know, but you can have a look on the site. And then you connect the DCC accessory decoder to that, and then come back to all of your Megapoints modules, and then you can use one DCC accessory decoder for all of them. Bear in mind that a DCC accessory decoder costs 30 quid off the Megapoints Controllers website. So if you've got to buy 3 of them for 3 of these boards, that's 90 quid you're going to have to pay. What I've done here is produced a single board which can drive, in theory, and I say in theory because I've never been able to try it, up to 16 of these. And that is the practical limit, because what you have to do is you have to set an address up on each of these boards with push buttons, and that address only has a range of 16 different values. So you can have 16 of these talked to by one of those, and 16 times 12 is 192, so you get 192 points. That's what I've attempted to do to make it such that that's how it'll work, but I haven't been able to fully test it because, as I say, before I'd finished that I've blown this up. So I've got most of the code working, but that's as far as I can go. As soon as I can get a replacement chip for that, I'm waiting for one from Merg, but they've also run out of stock of the boards, of the kits. I need another 2 kits, so I'm going to be buying those as soon as they come into stock. But what I can show you is the essence of how this little board works. Now, I say little board, it's in a breadboard at the moment, but it's just, this happens to be an Arduino Mini, Pro Mini, but an Arduino Uno would work, although it'd be much bigger, or an Arduino Nano would work as well. And with the Nano, this bit here, which is the USB interface that talks to it, that's all built onto the Nano board. So in a board that same size, you get all this on it as well, which is really good. But what you need is the DCC signal comes in on these red and black, and this actually comes from what usually connects to my programming track, and this is what's talking to it. This is my trusty power cab, and it will be talking to this board through these two. And what this little circuit does, tip it up again, what this little circuit here does is simply takes this voltage here, which is, you know, up to 20-30 volts peak to peak, and turns it into a safe 5-volt logic signal down here for the Arduino, so that the Arduino can read all of the data that is superimposed on this bus. And the way it does it is it just puts it into an opto isolator, so as this goes backwards and forwards it flashes the LED, which is picked up by the photo transistor in here, and the output of that goes into a gate and produces 5-volt logic. But it means that this high voltage is completely isolated from the Arduino, electrically isolated. It's actually picked up by light, purely for safety. Most accessory decoders will do something like that because they don't want to be connected to the track. You don't really want them connected to the tray. Not all of them will do it, but because I want to connect this to a PC, I don't want DCC going up my PC. So that's why I've done it that way, and I suggest that that is the way you would always do it. Other than that, all you need is the I2C interface on here. I've written all the code, I haven't built the interface on yet, which is just, all I need are 3 pins to be able to connect a cable to it so I can connect across to here. Then I can talk from this to that, then I can go from the other one of those little connectors to the next Megapoints controller, and then off that to the next one, and I can talk to 3 of them, which is what I want to do. But in theory I can talk to up to 16 of them. And that is what this project is all about. Now I've still got it connected to my PC, and the reason I've got it connected to my PC is just to give you an idea of how you set it up. I haven't made it such that you can press buttons on here to set up the address and the number of Megapoints controllers, because that might be quite difficult on here. It might be possible, but it would be a lot of code. I've done it by just commands that I put through the via the PC, because you only have to set up the address and the number of Megapoints controllers that you're using once, and then after that it will remember it, and that it will work forevermore like that. So what we're going to do is we'll go over to the PC and we'll have a look at what goes on, and I'll press some buttons on here and you'll be able to see what's happening. Just before we go over to the PC, this code that's running on here I don't claim all of the credit for. I picked up a piece of code off the internet which I think is called RG Packet Sniffer, DCC Packet Sniffer, which is something that's free in the public domain, and basically has been contributed to by 2 different people whose names I can't remember, but they're accredited in my software, and one of them wrote a packet sniffer that can actually read the packets and just show the 1s and 0s of the packets, and the other one I think then added human readable information, like whether it was a loco packet, an accessory packet, a CV packet, and what it was doing. So it was a loco packet, was it a speed packet, what direction was it set to, was it a loco function, all those sorts of things are available on it, and I have actually not removed that, so this will still work as that DCC packet sniffer. And what we do is go over to the PC and you can have a quick look at how the packet sniffer used to work. So here we are at the PC. What we need to do is we need to go Tools, Serial Monitor, and there we are, we've connected. And what you need to remember is, let's take that out of the way, what you need to remember is that you will need, if you use this, you'll need to set it up to 115/200 bits per second, and you'll need to set it up with no line end. Without doing that, it won't communicate properly. Okay, so what I'm going to do is I'm just going to send it a command to put it into Sniffer mode. What you see happening on that screen now is that every DCC command that comes into it is being displayed. Okay, right, so I'm now talking to 2 locos. Well, I should be talking to 2 locos, not quite actually. Let me just do it different. There we go, now I'll be talking to 2 locos. Okay, I'm talking to loco, I'm running 2 locos at the same time. I'm running loco number 3 forwards, and I'm running loco number 6632 also forwards. Let's just reverse that one. Right, I'm now running 6632 in reverse. Basically all I'm doing is changing values on here, and you can hopefully see my power cab now, and as I move this up and down, which is the speed of loco 6732, you can see that speed changing on the screen. And if I send an accessory packet, this will be to accessory address 1, you'll see that appear on the screen as well. There it is, going up the screen. So you see there's a lot of activity goes on a DCC bus. What we'll do is we'll shut all that up. So we'll stop 6732 I mean, and we will stop, whoops, loco number 3. So now everything's stopped. Now I've shut all the packets down, nothing's going on. But as you can see, that will show you everything that's happening on the DCC bus. And that's originally what the software was for. I have squashed it up this way a little bit so that it doesn't take up so much room on the screen, but basically it does exactly the same as it did when I first downloaded it. So what I did to this software is I intercepted it in various places to change what it does. And the first thing I intercepted it with was I said, I only want you to sniff packets. I don't want you to tell me what's going on with any of the packets. I want you to go into what I now call Megapoints mode. So if I press the M on the keyboard, appears up here, and then return, it's now says entering Megapoints mode. Now it will show nothing whatever I do. So if I come back and do this again and move this up and down for speed, nothing's showing on there because I've shut up all the packet output. So I've taken a lot of work off the Arduino already. And if I send an accessory address that belongs to this set of Megapoints boards that we set up, which I'll talk about how to set them up later, then nothing will appear on the screen at all. It will simply do nothing. So you don't need the PC connected. You can do all of it once you've set it up once. It will stay set up that way and you don't need a PC. The PC just allows you to set two things in fact. But if you want to use it as a packet sniffer, you go back and look at it as a PC. So that's the first thing. Now, as I say, you'll see nothing on the screen if I send commands to it to operate what would be a Megapoints controller if it was connected. So what I'm going to do is I'm going to show you what is happening by putting it up on the screen. And what I'm going to do is I'm going to go into Megapoints mode, debug mode, by pressing D and enter. Okay, now you get a warning there. Debug mode is on. Warning, this may cause missed packets. Because keep printing while packets are coming in. As you could see, all those packets flying in all the time. You keep printing while they're coming in, you can actually miss packets. And the reason that you saw all those packets before was that more than one packet is sent every time. And we will miss packets sometimes, and so will locos. Locos will miss packets due to the fact that they get intermittent wheel contact with the track, or there's interference of some other kind that causes them not to be able to see the packets. So yeah, the DCC has to keep doing it. For accessory decoders, which are less prone to losing connection anyway because they're hardwired, what you will find is, and if I send one accessory address now, I'm just going to press select accessory twice, which will send a command to accessory packet, to accessory 1. 1, 2. And you see there were 4 of them. It received address 1 for module 1, servo 1, and the command was off. And then it shows you there what the actual bits were that went out to the Megapoints controller. and then it tells you that it saved that to the EEPROM. Notice it only saved it once, no matter how many of those I did. Oh, sorry about that, I've just kicked the camera. That's why the bottom one flashed. It is still working, yes. Okay, so if I send a macro from here, which I can do by saying macro 1, this will send out lots of commands now. Macro number 1, I think you have to go enter. There it goes, and it sent lots and lots of commands. You notice it only wrote to the EEPROM once. There's absolutely no point in writing to the EEPROM after every command. It waits for the number of commands, accessory commands we're talking now. It ignores loco commands. It just waits until it's seen all the accessory commands, then it writes the information to the EEPROM. It's written the last values that it knows the Megapoints controller is set to. And that is the important thing, so that next time you switch it on, it knows the Megapoints address, it knows how many there were, and it knows what the last values were. So it can continue where it left off. This is an important thing in DCC. Now this is just, as I say, it's debug mode, so it's telling me what's going on. Okay. Now, you've seen what it actually does by going up, showing it on the screen. Of course, none of that is going to be seen when it's really in operation. So we'll be operating with debug mode off. Now debug mode is off. If I send that macro command again, macro 1, enter, you see nothing. Nothing at all happens, because we don't need to output it to the screen. So that in essence is what it's for, and the way it works, if you like. The way you set it up for its address and the number of Megapoints controllers, we can find out if we just reset the Arduino and get back to the beginning. There we go. So what we've done is we've gone back to the beginning. It signs on as what it is. It tells you what the base address is currently set to, which in this case is wait a minute, I'm sitting at such an awkward angle here, struggling to read this screen. Here it is, it's down here. The base address is set to 1, and the number of Megapoints, I hope I put my head in the way, I don't think I have. The number of Megapoints controllers is 3. Okay, so, and it then says the maximum allowed address is 2044, and this is command station dependent. In our case, the maximum address will be 36. It says that somewhere, I'm sure. It doesn't tell you that. Okay, doesn't matter. What I'm going to do is I'm going to change those anyway and show you. When it first comes, it will tell you that the address is set to 0, which is illegal. If you send it 0 address, nothing will happen, and therefore it will not work. And the number of Megapoints modules will be set to 0, which is pretty stupid as well. So what we will do is we will actually set a new address. And the way you do that, it actually tells you it here. It says you press P to set the base address, and then it waits for an accessory address, then uses it. So let's set the base address to 100. So what we need to do is we need to press P and enter, and now it says send the base address from the command station. So we pick up the command station and we say send an accessory, and we said we're going to go 100, 1, 0, 0, enter, and we need to send it something. We'll send off. Okay, and what's happened on the screen is that the base address is set to 100, the number of Megapoints controllers is 3, and the highest address is 135. It tells you that when it starts. So the first address is 100 and the top address is 135. That is because the first 12 take the addresses 100 to 111. The next 12 take the addresses 112 to 123. And the last 12 take the addresses 124 to 135. 36 addresses. And those addresses will be used. So if I was to send something to address 133, then that would go to the third Megapoints controller and servo number 10 out of 12. The other thing we need to set up is the actual number of Megapoints controllers we're using. Now I can change that, and the more you use, the more it has to write to the EEPROM every time. But that's okay. I'm assuming it's going to work. Again, I haven't tried it because I haven't got 12 Megapoints controllers. I will only have tried it up to 3. But let's have a go. So to change the number of Megapoints controllers, it told me how to do it, but I've forgotten. So press reset. Oh, excuse me, I've got hiccups. Press reset again, and it says N is to set the number of Megapoints modules. So we go N, enter, and it says enter the number of Megapoints controllers as a single character in hex. 0 to 9 or A to F will set the number of Megapoints controllers. Sorry. 0 to 9 and A to F. 0 will set the number of Megapoints controllers to 16. I am really struggling to read this because in order to get the camera around there without me knocking it all the time, I've had to turn the PC at almost 50 degrees to me so I can hardly see it. Okay, so what did we say we'll set it to? We'll set it to, let's say 10. So that will be A in hex. So we go A, enter. And now we see that the base address is still 100. The number of Megapoints controllers is now 10. And the highest address is 219. Because 10 times 12 is 120. We've taken 120 addresses now. Oh wow. Anyway, so that is in essence how you set it up and how you use it. Now it will say nothing whatever you do unless you go into debug mode or you go back into sniffer mode. When you're in packet sniffer mode there are other things you can change, but I'm not going to go into that. That information will be in the code, so you just read the top part of the code, the comments at the top of the code, and it'll tell you all that. But that in essence is what I've been working on for a while, and as soon as I get a working Megapoints controller, or preferably 3, and can test it and make it work and make sure it goes, then I will do another quick video on it showing you it working, and I will then post the code in the same way that I've posted my code before, so that you can give it a beta test. Any of you who want to try it, anyone who's got Megapoints controllers and who wants to play with it can. I'm not expecting many people to do it, but it's something that is there if you need it. So I hope that this video has been useful. There's been a lot of information there, and there may well be many questions that you've got. If you have got questions, then put them in the comments and I will answer them briefly in the comments. But if I get any questions that lots of people ask where obviously I've not been very clear, then I will do another video and answer those questions with a demonstration, hopefully after I've got a working Megapoints module. So I'm going to do one more video before Christmas. I can't do one on our 3D printed servo point controller because Hugo has run out of time before Christmas, Not surprised, Christmas is a very busy time of the year, so that will probably now not be done until after Christmas. So I'm going to do one more video where I'm going to tell you what I expect to be doing in the new year in order to get my Inglethwaite layout underway. I've got a few ideas of what I want to do, and I've been building a few odds and sods for it, so I'll let you know what that is in the next video, and that will also be my Christmas message video as well. So thanks for watching. As I say, any questions, put them in the comments, and I'll be back in a couple of days, I expect. So bye for now.